Welcome back to Bal Vigyan Bharati. Now here we will move on to the problem number 37 in probability. The problem is about a fair coin is tossed twice such a way that event E of having both heads and tail and event F of having at most one tail. Okay, so you have to find then probability of event E, probability of event F, and probability of happening E when F is already happened. So there are three cases. So you can understand that unless you get these values, you cannot reach there. So you need to find the values of the hierarchy that is being needed actually in the question. So the solution will start with the identification of the event. That event is said to be E, which represents having both head and tail. Okay, so in how many ways, if two coins, there one fair coin tossed twice, not the two coins, one coins repeatedly being tossed. So what could be the results of event A where head and tail can be the result of the tossed coin. So the result could be, if I start with all similar results, head head, tail tail. Okay, these are the two straightforward, and other way, first is head, second is tail, and first is tail, second is head. These are the only possible results when a toss being tossed for twice. Okay, these are probable result of event E, where they are saying head and tail both may be there. Okay, having both head and tail. It is not that head and tail cumulatively will come. There may happen that head may come, tail but the results will include both head and tail. There is no distinguished results. Only the head or only the tail will get. Okay, such a way. And the F event says event having at most one tail. That means whatever result you will get at most one. That means two tail is nullified. So out of this, head tail or tail head are the chances or the favorable results for event F. Event F says you have to having at most means the maximum tail. The maximum tail is 1. So in that case, you must consider this also, because at most means there may be possibilities that you won't get any tail also can be considered as your favorable result. At most means there must be some at least also. So at least, if it is at most is 1, at least must be 0. Negative is not possible to 0 where both the head are coming. So these are the cases. So if I further can analyze, I can get what are the intercept between. That means what are the common between E and F results. So these are the results. These are common: head tail, tail head, head head. These are the three results common. So here I am getting 3 results. Here I am getting 4 results. Here I am getting all 3. So 3 results here. Now if I want to calculate probability of event E, so probability of event E where head and tail is possible, out of the total results, it is that a fair coin is tossed such a way E event having both head and tail, so that means E event both head and tails. That means okay, this is not the event E. This is basically the probable all results. This cannot be the event E, because event E says both head and tail should come. It's not that only head or only tail will come. So these results are not a part of E. So this is the total possible results, okay, and E must be such that E must be what, both head and tail, that means head tail or tail head. This is the case where E is possible. E is both head and tail, that means it must not be only head or tail. So these are the cases where only head or tail is coming. So this is not the case E is having. So E is having head tail or tail head. Okay, fine. F is saying event having at most one tail. So at most one tail is, these two cases is okay, and at least one tail, that means there is no tail, zero tail. So this is also considered. So this is one result, and E having two results, and the total results is 4. So E intercept F, if I say, so this is the only two cases where they are matching. So this is 2 again. E intercept F, that means out of 3, E carries only these two favorable results. So probability of E is, the favorable condition for E is head or tail, that means 2, and the total possible result is 4. So that means is equal to half. Okay, probability of F where at most one tail, that means all 3 cases 3, and your total cases are 4. So this is 3 by 4 is the answer. And now we have to find probability of happening E when F has already happened. So that as per formula is probability of E intercept F by probability of F. This is the formula, and E intercept F is two results because HT or TH. So this is 2, and F, probability of F having probability of E intercept F is 2 upon the complete number of possible results, because the probability comes as number of that event by the total number of event. So probability of F is also number of that event is 3 and the total result 4. So that means this is nullified. So 2 upon 3 will be the result for E by F, that means happening of E when F has already happened. Understood? This is the total possible outcome. I made mistake initially, but while progressing, I can understand that E is the case where both head and tail must come. It's not that only head or only tail will come. That is not a part of, because that, but that also a part of the total outcome where both head, both tail, one head, one tail is the results are coming, while the possible result may come. Okay, so you can understand that. The next one is in a class 40% of the students like math, 25% of the students like physics, and 15% like both. So this is very straightforward. This is very easy one. The sums already you have done several times. So if I say the event of mathematics is 40% and event of physics is 25%, and event of the intercept, the both means that intercept. So students like physics and 15% both. So intercept physics with math or math with physics, interception is 15%. Okay, so if you wish, you can take the total sample space. So total sample space is of 100, and then this will be equivalent to 40, because this will mark as the number. Okay, then so number of the mathematics, number of, and this is number of this. So that can be used in the formula directly. So this is equivalent to this one. If I take the sample, that is the capital N is 100. Okay, now this is sorted out. Now the condition of the sum: one student select at random. Okay, the student is being selected depending on the subjects he likes, or yes, so subject he likes. So and random, find the probability that he likes physics if it is known that he likes maths. It is known that he likes maths too, means already it has notified that the person picked is liking the math, but what is the probability that he also will like physics? So that is a part of the interception. So now you have to find the probability of liking physics when math is already liked by the person picked. So this, if I once understand, so as all are there in the number, so either you can put it in a probability form or in the number form. So what in my case, the probability of physics intercept maths when I have to get the happening of P when maths is already occurred, and this is probability of maths. Now this can be also represented as number of P intercept, means quantification by n, or the number of M with the total sample space quantification. So this we know, this is how much M intercept P or P intercept, that is the same thing, 15 by 100, and this is equal to maths is 40 divided by 100. Okay, so ultimately this will become 15 by 40, or if we reduce it by the common factor 5, this will become 3 upon 8. So this will be a result. Understood? So we will move to the next problem, that is problem number 39. Okay, the problem number 39 says 3 bags contains 3 red, 7 black, 8 red, 2 black, 4 red, 6 black balls respectively. So if I put it as in a pictorial form, there may be 3 bag. Okay, there may be 3 bag. Okay, so 3 bag are there. So first bag, there are 3 red plus 7 black, 8 red plus 2 black, and 4 red plus 6 black balls are there respectively. One of the bag is selected at random. So out of this, one bag is selected at random and a ball is drawn from it. So once you pick a ball bag, you have to bring out one ball, randomly drawn from it. If the ball picked is red, so there is chances is picking red ball and black ball both. But once you pick, and if you see the color, if you see it red, then find the probability that the ball picked from the bag 3. So that means this condition only could happen the first you have picked the bag and then you picked a ball. Okay, you pick a ball, there are always a chance that you pick a ball from any of this bag. So this bag, each bag, bag 1, bag 2, bag 3, each bag is itself a sample space. Okay, in that sample space there are different number of red and black ball. You have to find the probability for each bag, because ultimately you have to pick the red ball. So there is a chances, because once you are not mixing these bags, the quantity of these bags, you will not get any common quantification of red and black balls. So individually the bags has a tendency or a different probability if they that are kept separate. Understood? So this bag itself a sample space where this much of red and black, and this also the similarly. So what is my probability of getting? So initially I pick a bag. So picking a bag is already done. Okay. So and the ball that I will get a red, that probability you need to find. So that if I see it is a sample space, the bag, so for a particular bag, let's say B1, the particular bag, okay, so that would denote the event against the sample space, because the bag itself is sample space. This kind of formula we have already, if in any sample space there are few events, we have already taken an example of two events A and B, and the probability of the event against the sample space, if I want to find, so if I add all this event against the sample space, I will get definitely one result. Okay, so because happening of any event is the not happening of the other events, so this formula lies good for happening of event A, and not happening of event A is similar to the happening of B. So as we know that happening of any event in the sample space plus the happening not happening of that event in that sample space is 1. Now this can be denoted as not happening of A, means if there is only two events, so this can be represented as happening of the other event, so that also give you. So in a similar way, there are two events in a sample space, so the probability of the happening of the one event against the sample space will be how much? The quantity of that event by the total quantity. That would be the case, isn't it? So if I go like that, so the quantity of that red ball is 3 and the total quantity in this bag is 10. So this is the probability. Similarly, the probability of red ball in bag 2 is in the same manner, will be 8 upon 10, and that of probability of the red ball in bag B is 4 upon 10. These are the individual results. Now these are the probability of red ball in bag 1, bag 2, bag 3. Now before than that, there is one more complication, is that you are picking any bag. First you have to pick a bag. The thing is that you have already picked a red ball individually. This is the probability individually, each bag. If I want to pick a red ball, these are my probability. But before than that, another thing is to be considered, where you are picking bag itself randomly. So that means there are always a probability of getting bag. Okay, probability of getting bag. So probability of getting any kind of bag out of the total sample space in the bag by the sample space. For this bag, there are bigger sample space, and individually the bags are also a sample space. So if I forget about the balls inside, only if I consider the bags, so they are lying on another sample space, where the probability of picking any particular bag, if I name it 1, 2, 3, any particular bag in the sample space, that will be the number of the bag picked, number of bag picked by the total number of bag, isn't it? So what is that? The number of the bag picked is only 1, and the total number of bag in the sample space is 3. So every bag has a tendency or the probability of getting 1/3 part of the sample space. Now my actual the probability that has to be calculated is probability of uh, probability of the the bag picked is third bag, and once a red ball is picked, so my event that is already happened is picking a red ball, and once I picked a red ball, then I will see whether that ball is picked from the bag 3. So my event that is to be confirmed happening is bag 3 against the event that has happened is red. So that also can be read as uh, that is also can be read as what, the favorable condition as picking uh, picking red ball from bag 3. Understand? Now this is similar to the Bayes theory. Bayes theory you have learned, where uh, the probability of any event against another event, okay, into the probability of the other event is equivalent to the is equal to the probability of the second event against the first event into the probability of the second event. So this is the formula. Now my answer has to be, this is my exact requirement, picking already a red ball, and that from the bag that has to be B3. So now this we know, the picking of red ball from bag 3 is 4 by 10. Picking any bag P3, so this is equivalent to this, because this is picking a bag from the sample space where that bag is lying. So this is definitely equivalent to picking any bag, either B1 or picking B2 or picking B3. Okay, so this is equal to 1/3. Now my probability of R, what is that? Probability of picking red ball. So probability of picking red ball, if I say like that, probability of picking the red ball from bag 1, or probability of picking red ball from bag 2, or probability of picking red ball from bag 3. So these are OR. So these are the chances. If I consider one bag, there is one probability of getting R. OR means, so that means why I am stressing on OR, because the possible outcome of getting red ball is the cumulation of the condition picking red ball from 1, or that means, if I say it like that, this numerator is okay, denominator is picking of red ball from bag 1 is how much? 3 by 10, and that is when I have picked red ball, one bag number 1. So this also to be considered, picking a red ball is 3 by 10, and from which bag? The bag 1. So that the probability of bag 1 is 1/3. Or, so OR means that will be added with plus. If it is AND, then I have to multiply. Now here OR, either this 1 or 2 or 3. So the result will be added together. So this is 8 by 10 of picking red ball from bag 2 when bag 2 has picked. So probability of bag 2 picking, so this can be read individually. If I say picking bag 1 and red ball from 1, so that's why a multiplication is coming for calculating the probability of individual bag. And when it is coming the cumulation of the all bags, these are coming with or. So you can understand the difference. Picking bag 1 and red ball from it, or picking bag 2 and red ball from it, or picking bag 3 and red ball from it. So this way the sentence will complete. So picking red ball from bag 1 and picking bag 1 and red ball from it, picking bag 2 and red ball from it, and picking uh, bag 3 and red ball from it. So this is the cumulative possible outcome, and this is favorable outcome. Now I think you understood. So this will become 4 by 30 on the numerator, and denominator all the LCMs are 30. So this is 3 plus 8 11 plus 4 15, 15 upon 30. So this will become ultimately 4 upon 50. Understood? So I will end up here. The next video I will start from problem number 40 and onwards. So thank you for now.